So today what we're going to work on are trig identities. So why don't you put me on pause, do the try this, and come back and we'll see what you have. Okay, so it says to draw the unit circle, put point P on the unit circle in quadrant 1. Draw in the radius and label the point. Okay, so I'm going to draw my unit circle. Remember, my unit circle is up, down, left, right, 1. It says put point P on the unit circle in quadrant 1. So here's point P. And draw in the radius. And we should know that the radius is equal to 1 because I went up, down, left, right, 1 unit. And this point, remember, a point can be labeled as cosine theta, comma, sine theta. All right, so now what I want to do is I want to drop the altitude. So I'm going to drop the altitude down. Kind of like how we started off trigonometry. And now I want to label this piece here. So this piece down here, my x value, remember, is whatever x value is in my point. In my point, my x value is cosine. So therefore, this length here is cosine theta. And now I want this piece here, the up-down piece, that's my y value. So that is sine theta. So then, since it is a right triangle, then I know this must be true. That a squared plus b squared is equal to c squared, which is the Pythagorean theorem. So now plugging in my 1, my sine, and my cosine into the formula, I'll get sine theta squared plus cosine theta squared is equal to c squared, which is my radius squared. So sine theta squared would just be written as sine squared theta. Plus cosine squared would be cosine squared theta, written like that, is equal to 1. That is called the Pythagorean identity. And what an identity is, it's an equation that is true for all values of its variable. So I could plug in any value for theta, and when I do sine of the angle squared plus cosine of the angle squared, I will always get 1. All right, so let's write down the Pythagorean identities. So we just wrote it before. The Pythagorean identity is sine square theta plus cosine square theta is equal to 1. Now, it doesn't have to be sine first. You can have cosine square theta plus sine square theta equals 1. So it doesn't matter which one comes first because addition is commutative. All right, so now there's other identities that come from the Pythagorean identity. So let's rewrite the Pythagorean identity. Sine squared theta plus cosine squared theta is equal to 1. Now, what if I take this equation and divide everything by sine squared theta? So when I divide everything by sine squared theta, well, sine squared theta divided by sine squared theta, anything divided by itself is equal to 1. Plus cosine, remember, cosine over sine is cotangent. So this is cotangent squared theta. And 1 over sine is equal to cosecant. So it'll be cosecant squared theta. So that's another identity. So we have the Pythagorean identity. We have a derivation that comes from that. You have to know those. All right, and then there's one more. So what if I take what I started off with again, sine squared theta plus cosine squared theta equals 1. And instead of dividing everything by sine squared theta, divide everything by cosine squared theta. So sine squared theta divided by cosine squared theta is tan squared theta. Remember, sine over cosine is tangent. Plus, anything divided by itself here is equal to 1. And 1 over cosine is equal to secant. So it'd be equal to secant squared theta. So there's 3 identities that we have here that you have to be aware of. And this one was cosecant. Okay, so flip it over and take a look at the back. Okay, so let's write down our identities that you have to know. So reciprocal identities. So sine theta is equal to 1 over cosecant theta. Cosine theta is equal to 1 over secant theta. And tan theta is equal to 1 over cotangent theta. Cosecant theta is equal to 1 over sine theta. Secant theta is equal to 1 over cosine theta. And cotangent theta is 1 over tan theta. All right, your quotient identities. So tan theta is equal to sine theta over cosine theta. And cotangent theta is equal to cosine theta over sine theta. All right, and then our Pythagorean identities. So those are the ones we just wrote down. So that is sine squared theta plus cosine squared theta is equal to 1. If I divide everything by sine squared theta, I get 1 plus cotangent squared theta is equal to 1 over sine would be cosecant squared theta. And then the other one would be, if I divide everything by cosine, be tan squared theta plus 1 equals secant squared theta. Okay, so now let's do some proofs. Okay, so look at number 1. I have here 1 sine theta times cosecant theta equals 1. Now, when you do a proof, what you want to do is show one side is equal to the other side. So don't do anything to one side. You're only going to work with one side. So I'm going to work with the left side. And what I want to do is I want to work down so I get 1 equals 1. So you want to work with one side, not the other side. All right, so let me just move that out of the way. All right, so we have sine theta. So I'm going to leave that as sine theta times cosecant theta. Now, cosecant theta is the same thing as 1 over sine theta. And I want to show that equals 1. So remember, when I multiply numerators, I multiply denominators. So sine theta over sine theta is equal to 1. Anything here divided by itself is equal to 1. So 1 is equal to 1, and that checks. Okay, so let's take a look at 2. So what I'm going to do with number 2 is I'm going to leave secant squared theta. I want to get the left side to come out to be secant squared theta. All right, so we have cotangent theta plus tan theta. All right, so over cotangent theta. So I'm just going to split this up. So this here is actually cotangent theta over cotangent theta plus tan theta over cotangent theta. And I want to show that equals secant squared theta. So tan theta over cotangent theta over cotangent theta is equal to 1. Plus, now what am I going to do with this here? Well, tan theta is sine theta over cosine theta over cotangent theta. And cotangent would be cosine theta over sine theta. Still equals secant squared theta. All right, so now this mess here. So I have a fraction divided by a fraction. So I want to do same, change, flip. So it'll be 1 plus sine theta over cosine theta times sine theta over cosine theta equals secant squared theta. All right, remember, when you multiply fractions, you multiply numerators, multiply denominators. So I have 1 plus sine times sine would be sine squared theta. Cosine times cosine would be cosine squared theta equals secant squared theta. All right, so now remember, sine over cosine would be tangent. So it'd be 1 plus tan squared theta equals secant squared theta. Now this is from our Pythagorean identity. So 1 plus tan squared theta is secant squared theta. So secant squared theta equals secant squared theta, and that checks. Okay, so that's it, and we'll practice in class tomorrow. Have a good night.